Hi everybody. So today we're looking at how to interpret two-way tables. Okay, so we're continuing our studies of analyzing categorical variables. And again, we know that two-way tables are a great way to show if there's any kind of relationship between two categorical variables. Okay, so in this first problem, it says, a survey of a random sample of ninth grade students from Alabama asked whether the students owned a cell phone and whether they had brought a personal electronic device to use for schoolwork that day. The two-way table of row relative frequencies below shows the data. So in this table, it deals with a random sampling, a random survey. Again, surveys are great with two-way tables, right? Two-way tables are a great way to display surveys. Those students who brought personal devices versus owning a cell phone. So here is owning the cell phone, and these are the personal devices. Based on the data, which of the following statements must be true about the ninth grade students from Alabama? Okay, so the first thing that I'm going to ask you is, if you look at this data, okay, it says it's row relative, correct? Which means if you look at the decimals, or the portions or the ratios, you'll see that if you add up 0.57 for the students that do not have a cell phone, if you add those who did not bring a device is 0.57, as opposed to those who brought a device, a personal device, is 0.43, it adds up to 1, correct? This is what we call row relative. When you add up the percentages, right, or the proportions or the ratios in a row, they're going to add up to 1. If this were column relative, then if you add up the numbers in the columns, they will add up to 1. So for the students who own a cell phone, 0.20 did not bring a device. 0.80 brought a device. Again, that adds up to 1. However, in this case, if you were to add up the columns, 0.57, those that did not bring a device, 0.57 and 0.20 does not add up to 1, correct? So there's no way that we can analyze this table by column. Okay, it doesn't make any sense because this does not mean that 0.57 of the students did not bring it and 0.20 did. These two numbers only relate to their rows, not to the columns. That's why they don't add up to 1 for the columns. Is that clear, guys? So we can't make any inferences based upon columns here. We can only make conclusions based upon the rows. All right, now that we understand that, same thing over here. If you were going to add up the students who brought the devices, well, those who do not own a cell phone are 0.43, but those who do own it are 0.8. So that's not going to add up to 1, right? That's 1.23, which makes no sense. So again, it doesn't make any sense for us to make any sort of inferences using the columns. All right, now let's go to the choices. Based on the data, which of the following statements must be true about the ninth grade students from Alabama? All right, so let's take a look at choice A. 57% of the students in the sample do not own a cell phone and did not bring a personal device. Well, unfortunately, this 0.57 doesn't relate to the proportion of the total number of students. It only relates to those who do not own a cell phone. Of the students who were surveyed, okay, of those students who don't own a cell phone, 0.57 or 57% did not bring a personal electronic device. That's what this 57 relates to. It doesn't mean 57% of the entire survey. All right, again, we don't know. We don't know that. This only relates to the row. It's row relative. So A can't be the answer. How about B? A student who owns a cell phone is less likely to have brought a personal device than a student who does not own a cell phone is, okay? So a student who owns a cell phone is less likely to bring a personal device than a student who does not own a cell phone. Again, we cannot compare between those students who own and those who don't. That would make it a comparison by column, right? So again, that doesn't make any sense. Right? So B can't be the answer. C, a student who owns a cell phone is more likely to have brought a personal device than to not have brought one. So let's see the students who own a cell phone. Okay, these are the students who own it, and definitely based upon those students who own a cell phone, it looks like students are more likely to have brought a personal device than not. And so it looks like that is the correct answer. Okay, and let's take a look at the last choice. So we'll just check on that. A student who did not bring a personal device is more likely to not have a cell phone than to have one. So up here, who did not bring, again, this is making a comparison who did not bring a personal device. So it's trying to make a comparison between these two numbers here, right? Of those students who did not bring a cell phone, more are likely to not have a cell phone than to have one. Again, we cannot make this comparison because this does not refer to the whole. Okay, these are not percentages of the whole. These are just percentages of the rows. Okay, so again, our only choice is C. Okay. All right, guys, let's look at the next one. Here it says, I believe it says, a sociologist polled a random sample of people and asked them their age and annual income. Okay. The two-way frequency table below shows the results. So we have annual income versus age group. Here is the age groups. Again, age is a number, but then again, they're in groups. So really here, again, this is a categorical variable, right? They're in these two categories, either age 44 and under or age 45 and above, right? And then their annual incomes. Okay, these are categories, those who earn less than 50,000 and those who earn at least 50,000. Okay, and here are the totals that are given here. Okay, so this is not a row relative or a column relative. It actually gives you the totals here. Okay, good. So which of the following statements is true of those polled? So let's go down. Let's take a look at them one by one. A person with an annual income of less than 50,000. So we're looking at these people, right? A person with an annual income less than 50,000 is more likely to be 45 years old or above. Is more likely to be 45 years old or above. And we can clearly see that that is not true. Okay, it's more likely they'll be 44 and under, right? Way more, right? That's over 4 times, right? Yeah, about 4 times. So, okay, let's look at the second one. A person in the 44 and under age group, so here, 44 and under age group, is more likely to have an annual income of at least 50,000. Well, it's 68 compared to 148, so that's not true either. It's the opposite, right? They're more likely to have an income of less than 50,000, which makes sense because the younger you are, the less experience you have, and usually your income is going to be lower than someone who has more experience. Therefore, their income is going to be a little higher, right? Okay. How about C? A person with an annual income of at least 50,000. So we're looking at these numbers here. At least 50,000 is more likely to be 45 years old or above. Is more likely to be 45 or above. Okay, that makes sense because here it's 68 as opposed to 94, right? So it looks like 94 is more. So I think that could be the answer. And let's look at the last one, just to make sure. A person in the 45 and above age group, so again, 45 and above age group, we're looking at this row right here. Okay. Is more likely to have an annual income of less than 50,000. is more likely to have an income of less than 50,000? No, that's completely untrue, right? 94 is way more than 38, so that can't be right. So therefore, I think C is correct. Okay, let's take a look at another one here. Okay. The two-way table. Okay, so here it says the two-way table of column relative frequencies. Okay, these are now column relative. See that? You add up the columns, they add up to 1. Correct? These are not row. So you cannot make any real conclusions or inferences based upon the rows, only by column. Okay? What does it say? Show data on how often a teenager's parents monitor their screen time and whether or not the teenager has time for their daily screen has a time limit for their daily screen times for teenagers in Westlake County. Okay, so here are the frequency of monitored screen time versus the time limit. Time limit for screen time. Based on the data, which of the following statements must be true for teenagers in Westlake County? Okay, so let's take a look here. Choice A. The parents of a teenager with a time limit. So the parents of a teenager with a time limit are more likely to never monitor the screen time. So there's never. Than the parents of a teenager with no. Again, it's trying to make a comparison, right, between the parents give a time limit as opposed to parents who don't. So A, we cannot make any inferences. Again, this is only column. How about B? A teenager whose parents occasionally monitor their screen time, who occasionally monitor their screen time, is more likely to have a time limit. Again, we're trying to compare this by rows, and it's not going to work because these are not relative to each other. How about C? A teenager whose parents always monitor their screen time is more likely to have a time limit. Again, that doesn't work because we're going this way, right? And finally, a parent of a teenager with a time limit, so we're talking about this, right? Those with a time limit are more likely to usually monitor screen time than to always. Are more likely to usually than always. And that makes sense because usually is 0.29, always is 0.11, correct? So that sounds pretty good. Okay, as long as we're comparing within the column, because this is column relative, not row relative. And that is correct. Okay, last one. Here it says, what is it? Alvaro is interested in the relationship between weather conditions and whether the downtown train runs on time. For a year, he records whether each day is sunny, cloudy, rainy, or snowy, as well as whether the train arrives on time or is delayed. Here are his results. So this is the results of Alvaro's observations, right? And how the trains are running, either on time or delayed for the various weather conditions. Okay, and now let's take a look. And he did that for a year. Which of the following statement is true? Okay, so this is not a row relative or just row relative or column relative, right? This is both. This is both column and row relative, so we can make comparisons between rows and between columns. Okay, good, because they give the totals too. Okay, they gave the column totals as well as the row totals. All right, and we see that the number on the bottom right, that is your total, 365 days per year. Okay, and if you look at these choices, okay, when the weather was rainy, it was more likely for the train to be delayed than on time. So when it's rainy, no, it's the opposite. It's 40 on time and 15 delayed, so that can't be it. When the weather was snowy, it was more likely for the train to be delayed than on time. Snowy, more delayed than on time. That looks like it. Okay, how about this one? More than half of the delays occurred on no. Well, if you look at the delays, rain, no. If you add these up, it's going to be more than a half. And then finally, none of